Okay, we are given the problem of a 5 kilogram block resting on an incline that makes a 30-degree angle with the horizontal coefficient of kinetic friction between the block and the incline is 0.2. The block is also released from rest. So part A says that we should draw a free body diagram. So as always, for free body diagrams, we should represent it as a dot, and I'll draw the incline right here. Okay, and mentions that there's a 30-degree angle. So this is 30 degrees. So to start off with this free body diagram, what I usually do, I just draw out the gravitational force, as it's the easiest one. So as we know, force of gravity is equal to mass times gravity. The x component of the force of gravity is force of gravity times cosine theta, or in this case 30, and the force of gravity for the y component would be mass times gravity sine theta. I mean, yeah, 30 in this case. So let's plot them out. So this one, we could write mg, this is gravity, okay? And the x portion, the x component would be perpendicular to the incline. So that would be around here. And the y component would be parallel to the incline. So that would be like this. Okay. And now we can just start labeling. Okay, so this is the x component. So this would be mass times gravity, cosine 30. Although that might not be clear, you can still hear my voice, so it's good enough. And for the y, it would be mass times gravity, sine theta. Now, you might ask, how do we get this? Well, if we use trigonometric ratios, we'll say that cosine 30 uh, anti cosine 30 is equal to the hypotenuse over like the x component. All right, so say mg over x, and we're trying to solve for x. X would equal to uh no wait, sorry, it's the x component over the hypotenuse, and we will multiply mg by both sides, and that would give us that the horizontal portion would be mass times gravity cosine theta. So that's how we got it. So basically, we use trigonometric ratios to find the vertical and horizontal components of the gravitational force. Okay, now let's find the frictional force. Yes, as it mentions that we have coefficient of 0.2. Now, as you know, we are missing one crucial component to find the frictional force. So let's use the equation. Okay, frictional force is equal to the coefficient times the normal force. Now you might be asking, how do we find the normal force? Well, the normal force is basically comes from Newton's third law. So basically, an object that pushes up on the object. So say I set an object down to the table. Say I set my cup down on the table. The force of 5 newtons. This table would send up a force of 5 newtons, keeping the object at rest at the table, and it wouldn't break the entire table. However, this works differently since now we're on an inclined plane. Okay? So if I set it down on the inclined plane like this, the force, the normal force, would be perpendicular to the incline, which would be this portion. So as you can see within our free body diagram, we can see that this horizontal component is also perpendicular to the incline. So the normal force would also be perpendicular to the incline. However, it would be going into the opposite direction. So from this, we could say that the normal force of a bend is equal to mass times gravity cosine theta, or 30. Okay. Now, from this, we can conclude force of yeah, let's just label this n and mg cosine theta. Okay, 30. Okay, so that means using the formula, plugging in all the values, 0.2 times mg cosine 30. Okay, and we'll start solving them later. But now, another thing that we can tell, see, this vertical component would be pointing in this direction. So if we want to determine um, where exactly the frictional component would go, since these two forces cancel out, the only force acting on the block other than friction would be the vertical component. The vertical component is pointing towards, I guess you could say, southeast. So that would mean that the frictional component would go, the frictional force would go in the opposite direction, which would be northeast. So you can draw on a free body diagram. So the friction component, we'll name it F of K. Okay, so we have F of N, components, mass times gravity, 30 degrees, and F of K. And we represented it all as a dot. So our free body diagram is complete. So we can check this. In addition, we've also found the normal force acting on the block. However, we haven't solved for it. So the normal force is mass times gravity cosine 30. Make sure to put your calculators into degree form. Otherwise, it would output uh something like 0.9 or something. Okay, so if we plug into the calculator cosine 30 in degree form, we would get something around 0.86. So mass times gravity, 5 times 10. In this case, gravity will equal 10, as always within these kind of problems in AP Physics. Mass is equal to 5 kgs. So G mass times gravity is equal to 10 times 50 newtons. Okay, now let's find N. Now F of N is equal to mass times gravity, which we can substitute for 50 times cosine 30. And cosine 30, as we know, is 50 times 0.86. For the sake of keeping this problem simple, we'll just round to like the nearest whole number. So we'll keep it at 43 newtons. Next, let's find the vertical component. So which would be f of g y is equal to mass times gravity, which is 50 sine 30. Now, as you might know, sine 30 is equal to 1/2. So we can just plug that in. That would equate to 25 newtons. All right, now we are all prepared to solve for the frictional force. So F of K is equal to 0.2 times the normal force, which is equal to 43 newtons. Now, since I don't want to do the math, I'll plug it into my calculator and it will output 8.6 newtons. So we have 8.6 newtons. So to determine the acceleration of the block, we shall use Newton's second law. F is equal to mass times acceleration. More precisely, F net, the net force, is equal to mass times acceleration. Okay, so let's determine net force. Normal force and the horizontal component of gravity cancel each other out, so what's only remaining is vertical component and frictional component, and they're both going in opposite directions, so we would subtract them from each other. Okay, so we would get 25 newtons minus 8.6 newtons would equate to, let me try doing this, 16.4. 16.4 newtons. Okay, so plugging this in, 16.4 is equal to 5a, since the mass is 5. Now, if we divide both sides by 5, we would get 3.28 to a. And don't forget your units, so acceleration would equal to 3.28 meters per second squared. That's it. Let's box in our answers. Let's do, where is it? Here. And there we go. There we have it. And we've successfully solved the problem. Thank you.